Today's lesson, section 7.5a, we're talking about more trigonometric equations. Here, for this type of problem, notice how theta is being multiplied by 3. Now remember, if you were graphing these equations, or this function, that would be considered your k value. And so since it's different than 1, that messes with your period. So here, it will also mess with the number of answers or solutions that we get for our equations, because it may stretch or shrink our trig function, and so then that allows more possibilities or less possibilities depending on how it moves. Okay, so remember 3 was a bigger number, so it kind of did the opposite, so it shrank our function. So here we should probably see more solutions that end up happening in between this 0 to 2 pi region. Okay, so if I'm looking at 2 sine of 3 theta minus 1 equals 0, I want to solve like I normally would. So try to get sine of 3 theta by itself. So I want to add 1 to both sides. Okay, and then I want to divide both sides by 2. Okay, now solve this like you normally would. Okay, so just assume that 3 theta is together. So think of what angle, which is considered the 3 theta, for sine would give you a ratio of 1/2. Okay, and we've talked about that problem many times. And so sine of an angle that equals 1/2 is going to be pi over 6 and 5 pi over 6. But now here, how about I give myself some more room? Okay, but instead of it being equal to theta, it's going to be equal to 3 theta, because that would be like the inverse sine of 1/2 gives me pi over 6, so then 3 theta is going to equal pi over 6 instead of just theta. So now let's talk about this as if you were looking for all the solutions. Okay, so here for the sine values you'd have 2 pi k for both, right? And that would have been a part of your final solution. So here for this, we want to divide and get 3 by itself, or the theta by itself. So I'm going to divide everything by 3. That includes the 2 pi k for both. Okay, that gives me theta is equal to, and remember you got to multiply by the reciprocal, so pi over 18 plus 2 pi k over 3. So it's like 2 pi over 3 times k. Same thing with this one. So theta will equal 5 pi over 18 plus 2 pi k thirds. Okay, now your region is between 0 and 2 pi. Okay, and you have two answers of pi over 18 and 5 pi over 18. So not all the solutions will work, but the reason why this is helpful is because it'll help us get the other solutions. So to use it, since it's 2 pi over 3, that means that every 2 pi over 3 you're going to get a solution. So we just need to add 2 pi over 3 to pi over 18 and 5 pi over 18 till we get all the solutions that end up being in between 0 and 2 pi. Now remember, 0 and 2 pi, so you can figure out where to end. If you converted this to 18ths, it would be 36 pi over 18. So it needs to be an 18th of a pi that's less than that for all your solutions. So if you go get a value that's over that, that means it's not in between 0 and 2 pi. Okay? So if I take 2 pi over 3, let's convert that to 18ths. So if I multiply both top and bottom by 6, that gives me 12 pi over 18. And so I'm going to add. So pi over 18, which is 1 18th plus 12 18ths gives me 13 18ths. Okay? And if I added it again, it would get me 25 18ths. So that's still okay. If I added it again, 12 plus 27 is going to be, 25 plus 12 gives me 37. And so that's greater than 36, so then I'm done with that one. Do the same thing with 5 pi over 18. So 5 plus 12 gives me 17. So that's okay. And then 12 plus 17 gives me 29 over 18. And now if you did it again, you get 41, which is greater than 36. So then now you have all the solutions to this problem. Now the nice thing about this, the number that's multiplied to your theta indicates how many more solutions you should have by that same factor. So usually you would have had 2 if you did it without doing this. So I would have had the pi over 6. I would have the pi over 6, and I would have the 5 pi over 6, so there would have been 2 answers. So the 3 actually tells you that your answers are going to be tripled. So I got 6 answers, right? 3 from each of the ones. And they come in pairs, so like these ones would have come together, and then these 2 would have come together, and then these last 2 would have come together. Okay? Or, sorry, I have those backwards. These would have came together, and then these would have came together in the same like regions. Okay, because you're kind of taking your unit circle and cutting it up into thirds, and so then because you're squishing it that much. Okay, let's move on to the next one. So here you have square root of 3 times tangent of theta divided by 2 minus 1 equals 0. So here, same thing. Solve for tangent of theta divided by 2. So I want to add 1 to both sides. And that gives me square root of 3 times tangent of theta divided by 2 equals 1. Divide by square root of 3. That gives me tangent of theta divided by 2 equals 1 over square root of 3. So now think about your unit circle. Okay, it's not going to be pi over 4 because that just has square roots of 2 and over 2. So then it's either pi over 6, which is square root of 3 over 2, comma 1/2, and pi over 3, which is 1/2, comma square root of 3 over 2. Okay, pick one to see which one gives you that ratio. So I'm going to pick pi over 6. So 1/2 divided by square root of 3 over 2, multiply by the reciprocal. 2's go away. You get 1 over square root of 3. So that's my ratio, so that's the angle that I want. So theta over 2 should equal pi over 6. Now another solution would have been, because you're looking between 0 and 2 pi, right? Okay, would be on the opposite side here in the third quadrant, because since you have a positive ratio of 1 over square root of 3, it would happen in the third quadrant. And so then that would have been 7 pi over 6. So theta divided by 2 equals 7 pi over 6. Okay? So now, even though you're not doing the same thing, it's like half of theta. So you want to multiply both sides by 2 to get theta by itself. So theta equals, and we can do the same thing for our period. For tangent, remember it's pi k instead of 2 pi k. And so then now that becomes 2 pi k. So pi over 3, because these would have reduced to 1/3, plus 2 pi k. And let's add that in as well. So multiply both sides by 2, and then multiply by 2. So then this theta would equal 7 pi over 3 for every 2 pi k. Now let's think about our answers in between 0 and 2 pi. Okay, so now pi over 3 is okay, so that's a solution. But if you think about 7 pi over 3, is that in between 0 and 2 pi? No, it's not. It's greater than 2 pi because 2 pi is the same thing as 6 pi over 3 if you made common denominator. So since that's greater than 6 pi over 3, it can't be a solution. So the only solution you have in between 0 and 2 pi for this entire thing would be pi over 3. So And think about your period as well, because if it was a half of theta, your k value would have divided it, so it would push everything out and extended everything outside of your region that would have made sense. Okay, so that's why we only have one solution. Okay, have fun.